The simplest form of digital manufacturing tool can be broadly described as being able to cut in two dimensions at once. This is within the boundaries of the X and Y axis of the machine, the length and the width of a piece of material. Often, these tools are used to cut the outside profile of shapes and can be useful for quickly producing the basic components that are assembled to produce a more complex object, be that for pattern cutting in the manufacture of a garment or metal blanks in the assembly of a welded sculpture. Often, these machines feature a cutting tool that is energized and cuts using the utilization of energy, be this in the form of hot gases in plasma cutting, focused light in laser cutting, or highly pressurized fluid in water jet cutting. Other machines, like a plotter or drag knife, also operate similarly, although they utilize a passive cutting or marking tool. As these machines work on the XY plane, we describe them as cutting in two dimensions. As such, we are limited to only cutting or marking the outline of a shape in the material. We are not able to produce more complex shapes by varying the depth of the cut as we can with other digital cutting equipment. If we want to create more complex parts, geometries, we may be required to utilize more traditional shaping approaches after the part has been cut from the stock material. With any cutting tool, we must take into account the kerf or width of the blade when we are developing our cutting strategy. With simple tools such as plotters and bladed tools, our kerf is a known variable and we can choose to offset this from the outline to produce a part of a known size. When we use an elemental cutting tool such as laser, plasma or water jet, our cutting tool is shaped in the form of a cone. This makes calculating the kerf a little more difficult as it increases in size as we cut through the thicker material. Kerf can be negligible in materials that are only a couple of millimeters thick. However, as the material becomes thicker, the taper left by the tool becomes more and more noticeable. A poorly set and focused machine can exacerbate the effect. With plasma and laser cutting, an additional feature of the cut can be noticed, that of the heat affected zone. As the cutting tool moves through the material, it burns a path that leads to the cut being produced. In cellulose materials such as paper and card and wood, this leaves a sooty residue which may need to be removed from the part with a solvent or abrasive tool. With plastics and metals, the heat affects the underlying structure of the material and creates an area close to the cut which is harder and or more brittle. This can lead to additional steps being required in post-processing if, for example, an edge is to be profiled or a hole to be tapped.